Hello, my name is Bob D. Hilster and I am your particle model guru. Got a question from one of my listeners about space travel, and this is Michael's question. He asked, what are the implications, if any, for deep space propulsion that come from an understanding of the reality via the particle model? Does it open up some new avenue that can make traversing intrasolar or even interstellar, that is within our solar system or between stars, make the distances feasible in a way that the standard model does not? It's a good question. You'd really love to see that this new model helps. Okay, we've got some great ideas. Well, I already have covered in a video, the title of a video that I've already presented was called Faster Than Light versus Drag. And that's the link to it. You can view it again, and I'm not going to repeat everything I explained there. But the conclusion from the video is that that matter made of atoms and molecules will not, get myself straight here, will not move faster than light. But the particle model is not setting any arbitrary limit as in special relativity. Special relativity, they make observations, see that they don't see anything going faster than light. And so they say there's a limit. But there is a physical limit on atoms and molecules caused by the drag of the G1 particle field. So we're saying there's a limit, but there's a physical reason for it, not just arbitrarily saying it can't happen. When you start saying something can't happen, you automatically limit the possibilities of what you can do. And that's not something that we humans would like to see. We'd like to see that we have opportunities for doing things. Well, conversely, the G2 particle must move faster than light in order to cause light to bend or change speed. So faster than light is possible in TPM, but it is for the G2 particle, not for atoms and molecules. The atoms and molecules, as I described in the other video, will experience drag that keep it moving. That will keep it moving very fast. But G2 particle model doesn't exclude faster than light, but it's the G2 particle that moves faster. Okay, so let's talk about the spacecraft and people, because that's what Michael was asking in travel. And due to the drag on atoms and molecules, the particle model doesn't hold much hope for faster than light travel. Sorry, I wish I could give a better answer, but that seems to be the case. However, in communications is something different. Today we use radio signals, and that's the G1 particle, to communicate. And the G1 particle moves at speed c, so we get very good, high-speed, rapid communications. But I don't know why I say that, but it's much slower than the speed of light. No, it is the speed of light. That's what I meant to say. Maybe someday someone might invent a machine that can control the G2 particle, and we could have faster than light communications. After all, nature does it. The stars emit G2 particles. Okay, initially they're at random, it's a random field of particles as proposed by the particle model. But G1 particles are also emitted at frequencies. Within their range of ability, there are frequencies anywhere from radio up to gamma rays. Does nature do that? Does nature provide frequencies in a much higher band of frequencies for which we could use to communicate? Okay, that doesn't help traveling, but it could help communications. Could help. Let's talk about propulsion. Propulsion in a spacecraft requires that the propulsion object, be able to push the spacecraft. And the G1 and the G2 particles generally pass straight through the ship. And they push a little, and if you could generate enough of them, yeah, you could push. Probably not very efficient. Nucleons emitted at a high rate will push the spacecraft, but that's exactly what we do today. We can use standard propulsion to go faster and faster, but the spacecraft and humans are still limited by G1 drag. So it's a tough problem. Well, there has been proposed that we could use solar sails on spaceships and sail the ship just like people sail on water. Solar sails, also called light sails or photon sails, are a proposed method of spacecraft propulsion using radiation pressure exerted by sunlight on large mirrors. Clearly, light reflecting from a mirror is pushing the mirror at the same time and at speed c, if the mirror could move that fast. But again, drag is still the problem. But let's dream a little bit. Let's not limit our thinking just because I keep saying drag is a problem. Let's develop a new material. How you do that, I don't know. We're going to develop a new material that blocks the G1s from going through. If this shield is placed at your destination, it could reduce or eliminate the G1s coming from the spacecraft and hence reduce the drag. So that would be interesting. Reduce the amount coming at you head on, and there's no drag or little drag. Maybe you could move, maybe you're not going to move faster than light, but you're going to move faster than normal doing that. There's going to be side effects. Without going into a lot of things that might happen, the result of blocking the G1s is actually going to push that material towards the spacecraft. It doesn't seem right now, but you got to continue dreaming. You got to keep thinking. What would you do to? Could you have? I haven't put this down. Could you have a deflector that somehow deflects the G1 particles that you're running into? I don't know. It always seems like, it's a nice idea, but it doesn't look like it's going to work. Got to continue to dream. You never know what's going to happen. The material is going to be invented. Some machine is going to be invented to let some of these things happen. But there are possibilities. It seems like the good news is that the particle model provides options that other modules don't even suggest. At least you got some idea, something to work on, to think about. We need to keep on dreaming and apply these possibilities that the TPM offers, or any other model that might help us. So maybe in the future, things can happen. Humans can develop new technology that may help us in space travel. But ultimately, this is the reality of the question, and that's what the Michael was asking, is what about the reality of TPM? But it's not the reality of TPM, it's the reality of nature. Nature is only going to let us do so much. We're going to be limited by the physical nature that we live in. Whether it's we're not going to be limited by our laws. We're not going to be limited by our equations. We're going to be limited by nature. Whatever nature allows us to do, And that's probably what we're going to be able to do. But we still dream. My name is Bob DeHilster, and I am your particle model guru. Tune in next time when I'll explain more of the universe using the particle model. Thank you for your attention.